Airmaster produces industrial products in the form of ventilation units, and we wish to guarantee that our products work as intended in all climatic scenarios, in all user scenarios, and we need to be able to also to document safety and performance and functionality of the units. Also, we often have a need to assist in quality control by testing samples of our products from the production, or by taking part in fault detection and diagnosis in case of claims or in case of products that have failed in the factory acceptance test. And for all these uses, we need to be able to control how the conditions are that the tests are performed under in order to have reliable results and make valid conclusions. Airmaster has two sets of test facilities, an old one and a new one. The old one dates back all the way to 2011, so about 13 years old, and it's a double climatic chamber where in one room we can simulate in a realistic fashion outdoor climate in the form of temperatures and humidities, and then we have indoor climate where we create a room which is similar to a large classroom, basically. We have a ceiling that we can, where we can control the ceiling height all the way up to 5 meters high, and with any inclination we want. And then we have basically an outer wall where we can mount the Airmaster unit, so it works in a realistic fashion in terms of climatic conditions. Then we can study both the performance of the unit, and we can test various functionalities of the control system. So what we would typically study in the indoor climate would be experienced sound pressure level that a user will be subjected to. And then we would also look at airflow in the room and consider if the unit is able to ventilate the whole room and create a good indoor air quality, and if we can avoid draft. So we are looking at both atmospheric indoor climate and thermal indoor climate. With regard to the outdoor climate, this is something we use a lot to define if the control system of the unit is able to handle very cold or very warm conditions and still work in a controlled manner, in a stable and controlled manner. And an important thing would also be to consider condensate in the unit. If we have humidity from the indoor climate and very cold outside, we could have condensate forming in the units in places that are unwanted. This can create damage to the building or to inventory in the room, and we must be certain that this never happens in any cases. So for these uses, we need to be able to control the climates in a well-defined manner. Our second test facility is much newer. It has been created within the last 2 or 3 years. This is also a double chamber arrangement, where in one part of the facility, this is a reverberation chamber, as it is called. This has something to do with measuring sound power levels, so we can place an Airmaster unit and measure how much energy in the form of sound leaves the unit. And this is combined to a test rig for measuring airflow rates, This is very simplified drawing, but we measure here somewhere how much flow, how much volume flow goes through the unit. And there's an auxiliary fan that can help maintain a certain pressure in front of the unit. And in this way, we are able to measure how much sound is emitted from the unit at a certain flow. Why are we so interested in that? This is because a certain flow rate of fresh air at a certain temperature and at a certain sound level is in fact our product. This is what we are selling. And this is the quality of the unit that is most prone to being questioned, to sort of that people might be skeptical about. So it's important for us to be able to prove that that our documentation is right. So this facility is made according to the best international standards. The facility is also automated. So all data collection and data treatment happens automatically. Reasons for this is that we want to make sure that human error is impossible. And if there are any systematic errors, we can find them and we can correct them. Also, the fact that the facility is automatic makes it possible to use outside normal office hours for testing. It can run in the night or in the weekends. Makes it possible to make many more tests than we usually would be able to. And the point of this is that we want to assist in quality control by making enough tests to make statistical analysis. And you need a lot of tests to be able to do this. And this is now possible for us. In general, we have seen an increasing demand from customers for documentation of all kinds. We receive very many questions of all kinds of documentation. We also perceive an increasing interest in general in society towards good indoor climate and environmental friendliness. So the customers increasingly want to be sure that they are making the right choice, and so they need correct and elaborate data. Probably it also has an importance that Airmaster has grown a lot, so increasingly we have professional customers who know what to ask for. The Danish Technological Institute in Copenhagen, they have helped us define what are the right international standards to follow. And they have also helped us develop the methods to make sure that we follow the standards. Also, they have checked by measurement that the results is correct, that we are making the right measurements. And in general, it has been a great help for us that the Danish Technological Institute has many years of experience with this type of measurement. So they have, let's say, knowledge and experience, and they are considered a national resource on this type of subject. Both our test facilities, both the old one and the new one, are used practically every day, and even in the nighttime and in the weekends, since they can run automatically, and they are used throughout all the products' complete life cycle, straight from very early model experiments through optimization of prototypes to collection of master data on final products and to fault diagnosis in case of claims from customers. Also, they were very important during the recent component crisis. So when we needed quickly to find compatible components instead of those we could not buy, it was very important for us that we quickly could make reliable tests in our test facilities. It's a great advantage for us that we are able to create practically any situation quickly, because our test facilities are designed for quick reconfiguration. They're very flexible, so we can do a lot of tests. It is also important that we can test models and prototypes in well-defined conditions. Otherwise, we would not really be able to trust the results, and we would make wrong conclusions. A couple of examples of this: we need to document how do our units perform in terms of sound emitted. And if we didn't have the test facility, we would need to test in real life buildings, and it is practically impossible to measure sound from technical installations in real life buildings, because there's always something going on. There's always something disturbing other sounds from people or from wind or other installations or from traffic or something. So when we can create a reliable situation where we can measure sound from our unit, we are better able to guarantee for our customers what our units do. Another example would be outdoor temperature conditions. We need to be able to guarantee that our units function at certain outdoor temperature conditions. For instance, in Denmark, we have a dimensioning outdoor temperature of -12 degrees Celsius. And we have to test what the unit does in these conditions, and even what it does if it's colder. How does it react? It must function in a reliable and safe way. And if we didn't have the test facility, we would just have to stand around and wait until it's cold enough, which we don't know when it would be, and we are not able to repeat the process if we're not happy with the results. So by having the test facility, we can create the conditions we want, and we can repeat as long as we want until we are satisfied with the result. Well, now I've spent a fair amount of time on analysis of competitors, and I can say that Airmaster, compared to most competitors, we are able to deliver comprehensive and realistic data. Also, we can ensure operation in all relevant climatic conditions, and together with appropriate and effective emergency procedures. Once in a while, anyway, a fault happens. In these cases, we are able to quickly investigate what went wrong by creating the situation that went wrong and correct it. Also, quite often we have been able, in unusual projects where, let's say there's an unnormal ceiling height or ceiling inclination, or there are obstacles in the ceiling, we have been able to create the situation before it is even built one-to-one, and determine if we have a good solution or not, and what the solution might be. So we can help, our facilities can assist in the sales process in this way.